Today we are discussing Ohm's Law, and I'm going to go ahead and write the Ohm's Law formula down. So here we go. It is going to be E is equal to I times R. And this basically is Ohm's Law. And let's see if we can't just get a basic understanding of the properties, okay? So E stands for what? Electromotive force, right? Which in our case is going to equal voltage, okay? And I want you guys to associate voltage with a property that you know of, which in our case would be like the pressure in a circuit or the horsepower of the circuit. Now, let's look at I. I is intensity on the scientific formula, but we're going to call it what?
Amps.
Well, let's just call it, in our case, let's put an association of a word with amps, something that you're familiar with, and that would be the amount. So let's just go ahead and use the word amount. I know you guys understand that. So this is the amount of amperes flowing through a circuit. Okay? Does that make sense to you? All right. Now, the R stands for what? Resistance. And we actually use a unit measurement of ohms to calculate how much resistance is in a circuit. And again, now let's talk about how all these interact with one another. In our case, these two are what? Inversely proportional. So amps and ohms. So if my ohms is going up, my amps is going what? Down. If the amps is going up, what happens to the resistance?
The ohms went down.
It's going down. And like I said, inversely proportional. Now, a lot of times voltage and amps can what? Travel together. They're what? Proportional. So in our case, if voltage is going up, amps could be going up as well. So let's work with this formula a little bit. Like I said, we're going to turn this into a truth table. And so how many people has had algebra in class before? And you're always solving for x. Well, that's kind of what happens with this. We're going to solve for the unknown. If we have two of the variables, we can solve for the third. So, all right. So let's look right here. And this is kind of how it's going to lay out. We're going to put our voltage here, amperage here, and ohms here, which is the resistance, right? So let's say we have a 12-volt circuit. And let's say we don't know really what the resistance of that circuit is, but we do have 2 amps flowing through it. Okay? So what we're going to do is basically take and divide 2 into 12, which is going to equal what? 6 ohms. Now, that is a true table. We have 2 times 6 is 12, and that is true at that point. Does that make sense to you? So now we just solve for the unknown. So let's work with that variable some more. We have, let's say, for instance, we don't know what the voltage is in this case. It's the unknown factor. But, Matthew, I do have, in the case, I got 3 amps, and I know, we calculated, and there was basically 6 ohms in that circuit. 6 ohms. Okay? What would be the unknown voltage in that case? You would take, now remember, this is our division line, this is our multiplication line. So,
okay.
So you would multiply 3 times 6, and our unknown voltage is what? 18. Very good. So you kind of got an idea how this works? Okay. So let's try some more. Let's say, for instance, we don't know, really, we've got the voltage in this case. We know what the voltage is. We don't know for sure how much amps we have, but we do know we have 3 ohms of resistance. How many amps would be flowing in that circuit right now?
4.
Because all I would do, I'd take 3 into 3 into 12, and I would have 4. We multiply these, 4 times 3 is 12. It is true, we know it to be right at that point. Does that make sense? Okay, are you guys ready to try your hand at this? Okay, what we'll do, I will give you a word problem here, and see how you do. So, who'd like to come up first? Okay, now, in this particular case, we do have a 12-volt circuit, so I'm going to let you plug the value in, 12 volts. Okay, and we do have 2 ohms of resistance. Could you tell me how much current will be flowing in this circuit? And you come up with 6 amps. Is he right, class?
Yes.
Absolutely. He's done a good job. Let's give him a hand. Good job. Okay, now, we've got a 6-volt circuit. 6 volts, and there was a measurable of 6 amps in this circuit.
1.
1 ohm of resistance is what he saw. Let's give him a hand. Did a good job. All right, Jarvis, you want to give one a shot here?
Job to go last. Well, I'll make exception.
12-volt circuit. 4 amps flowing in the circuit. How much resistance in that circuit? Wow, look at that. Pretty good job. All right. I feel like the Ohm's Law principle is well understood. I believe we have Mr. Perry here. Would you like to try one?
I feel like Derek.
Oh, let's go, Perry.
And he says yes. Okay. So if you would, Mr. Perry, we're going to give you a real tough one here.
I feel like we should get the cameraman a shot at this.
Yeah,
So,
get the camera.
that's what I'm saying. Here we go. In this particular case, we have got a 9-volt circuit, and I do have 9 ohms of resistance. How many amps would flow in that circuit? 1, and that is the correct answer. Give him a hand. Good job. All right. Okay.
Yeah.
Any more questions whatsoever? You feel like you guys understand Ohm's Law? Any questions?
Cameraman.
What about
a shot at
cameraman?
it.
And so, the cameraman, would you like to come and try one?
You can do this. You can do this. You got this, Dom.
Here's the cameraman.
Dominic, try to.
We have got a circuit here. 1 volt.
Whew.
It has 1 ohm of resistance. What would be the amperage flow in the circuit?
Ooh, you got it wrong.
Very good. Why is that? It takes
Because
1 volt.
Here, 1 amp to 1 ohm of resistance.
Good job. All right. Perfect. All right. Thank you very much. Let's give Matthew a hand.